Okay, here we go. So remember, the derivative tells you the slope of the tangent line at a particular point. Okay, so when you are finding the derivative, and let's say you have this function, the derivative is giving you a gradient function, which allows you to find the slope of a line that touches the curve at exactly one point. Okay, the derivative is the gradient function, and then when you plug a value in, it's actually giving you the slope of that line, of that tangent line. Okay, so when it says find the gradient of the tangent line of that function at x equals 1, that's basically asking you for what is the slope of the tangent line for this quadratic at the value of 1. Okay, so first, what's the derivative? It's going to be 2x minus 1. And then you're going to plug in 1 into the derivative. So then that's equal to what? 1. So then that means the slope of the tangent line at that particular x value is 1. Y'all remember this?
Oh, yes.
Okay. Do you remember how to write the equation of a line? What's the equation of a line in general?
Oh,
Y equals mx plus b.
okay.
Or you can use point slope form, or you can use standard form. Okay? Realize that standard form, just real quick, is ax plus by plus d equals 0. If they ever ask you to write in that form, a lot of times they'll have this as well, which means that a, b, and d have to be integers, whole numbers, positive or negative. Okay? Don't forget about that. We are going to do an example, as you can see here. And what I'll do is I'll write them in all three forms, just so that we can get the practice or refresh and remember how to write equations of lines. So, again, you use the derivative and plugging in that x value to help you write equations of tangent lines and normal lines. Remember, the normal line is perpendicular to the tangent line. Okay? So, if I take that last example, what was the slope? 1. So then what would be the slope of the normal line? Negative 1, because remember it's opposite reciprocal. Okay. So in this one it says find the equation of the normal line f of x equals 2x plus 1 squared at 225. You always need a point when you're writing the equation of a line, okay? Or you need something to help. So we have our point, we just need our what to write the equation of our line? We need the derivative because we need to do what? Find the slope, okay? So on your desk, I want you right now to find the derivative of that function. So what is the derivative of the function? 8x plus 4. So this is our derivative. How do I find the slope? Plug in 2. So this would be 8 times 2 plus 4, which is what? 20. Now that 20 represents the slope of which line? The tangent. But it's asking us for the equation of the what? Normal. So what is the slope of the normal line? Negative 1 over 20. Okay? So now that you have your slope of your normal line, you're able to find the equation of it because you have a point and you have the slope. So real quick, I'm going to take that slope, I'm going to take that point, and I'm going to do it all three ways. There's slope-intercept form, there's standard form, and what's the other one? What? Not x-intercept form. Yeah, slope-intercept, standard, and then there's...
You want me to point it out?
It gave y'all a hint. Y'all hear what it said? Point slope. There we go. All right. So point slope form. Remember that is y minus y1. What's y1? Okay. Right. Y minus y1 equals mx minus x1. What do x1 and y1 represent? The coordinate. So what's my y coordinate? 25. Then my slope, and then my x coordinate. That's my equation in point slope form. If it doesn't specify how to write it, you can always write in a point slope form because you have a point and you just found the slope, and it's the easiest. In my opinion, it's the easiest. But a lot of y'all are going to resort to slope intercept form, which is fine. Okay. Slope intercept form. That's when you go and you take the y value, the slope, and the x value, and you use it to find your y-intercept. What is negative 120 times 2?
Negative 110.
How do I solve for C?
Okay.
Add 110.
Both sides.
So what's 25 plus 110?
251 over
251 over 2. So my equation in point slope form would be negative 120x plus 251 over 10. I definitely like point slope form because that's a nasty looking fraction. But those nasty looking fractions are what's going to help me get it into standard form the easiest. Remember, standard form is ax plus by plus d, which means that my x, my y, and my d need to all be on the same side. How do I make this to be all on the same side? Subtract y. That's the easiest way. Subtract the y over. Now, are all of these numbers integers? How do I make them integers? Multiply them by 20. By multiplying them by the common denominator, it's going to cause my fractions to go away. So now I have 0 equals negative x minus 20y plus 402. 502. And that is my equation in standard form. Either one of these is acceptable. If it doesn't say, it is your choice. However, if it does tell you what form to write it in, you do need to know how to write it in those respective forms.
Find the normal slope.
Yes.
That's the reciprocal, correct?
An opposite reciprocal, yes. Normal line is opposite reciprocal. Questions? Is it coming back? Somewhat? Okay. All right. Well, on your desk, I want you to do this example. Let's see how many of you guys remember how to do a problem like this. The gradient of the tangent line to the graph that's given is at -1 is 1. Find the value of k. So on your desk, I want you guys to see if you remember how to do a problem like this. So on this side, how'd you start? Derivative, which is what? 4x plus k. And then what do I need to do from here?
Since you know that like at -1 the derivative, like the slope is going to equal 1, so you say equal to 1 and then put in -1 for x because you know that value and you solve k.
Yes. So since you know the derivative is equal to 1, you set it equal to, and the x value is -1, so you plug it in. And so then on this side, what's the value of k?
5.
The value of k is 5. It's -4 plus k equals 1. K is 5. Okay? Yes?
Why do you set an equal?
Because right here, when it says the gradient of the tangent line, aka derivative, is 1, derivative equals 1. Mm-hmm.
I thought that was the gradient. Yeah, I thought it meant like the slope.
No. The slope of the tangent line. The slope of the tangent line is the derivative. So exactly. Different wording, but the same thing. All right. Here's another one. Curious. Let's see if you guys can do this one. On your desk. Okay. So in this one, on this side, where'd you start? Someone different. Haley answered the last one, so someone else answered.
Okay.
Where do we start?
Where do we start? Well, we find the derivative of x cube root,
Cube.
square root of 3
Cube root.
times ln x.
Okay, so I need to find the derivative. And what'd you get for the derivative?
The derivative, I got 3x x to the second power ln of x plus x squared.
Did you guys get that for the derivative? That is the correct derivative, okay? And so then from here, Danielle, what do we do? Dear group, your section if you're hanging today. So,
Well, don't you set like the derivative equal to 0?
how do you know it has to be equal to 0?
Because the tangent line is horizontal.
Horizontal lines have a slope of, very good. Over here in this section, someone different from who answered my last one.
Factor out x squared.
Factor out an x squared, which leaves me with what?
3x plus 1. And 0 product properties is that both of those equal to 0.
0 product property, you said both of these equal to 0. And what are my final answers?
Well, one of them is 0.
The other one,
Negative 1.
-1/3.
Oh, because it's okay. Wait, no, but it's
Hold
ln
on.
of x.
A equals ln of x, which is what? It's this
yeah,
one.
it's not.
This one is undefined. There's no solution where the natural log is a negative. So my only solution is 0. Okay.
Can you tell me like where
Yeah.
I was gonna say
So it's first times the derivative of the second. That's right. Plus the second. Second. So I should have been ln. That's right. Okay. All right. Last little bit. Okay. Incorporating some trig. That's what I want you to do on your desk. Okay. I have f of x equals cosine 2x. And we have to write down the value of f of power of 3. Find the derivative. And then write the equation of the line. Okay. So for this one, Danielle, what is the value of f of power over 3?
negative 1.
-1? Not a -1.
Oh.
It's -1/2. -1/2. Because when you go to plug it in, it's basically going to be 2 times pi over 3, which is 2 pi over 3. Cosine of 2 pi over 3 is 1/2. Unit circle. Multiply that by 2. Now I have to write down the derivative. Aiden, what's my derivative?
Negative 2 sine 2x.
That's very correct. Now I have to find the equation of my tangent line at that particular point, pi over 3. Erquin, in order to write the equation of my line, I need what? What do I need? I need my slope. How do I find my slope? Into the x, yes. So when I plug in pi over 3 into the x here, what do I get?
I got 2 square root of 3 over
2 square root of 3 over 2. Positive or negative? Should be negative because we got that negative on the outside. And sign in the second quadrant is positive. So my slope is -2 root 3 over, did you say 2 or you say 3? 2. And they reduce some more to be just negative square root of 3. So I have my slope, and I actually have my point too. When I found this right here, I was finding the y coordinate of my point. So I now have pi over 3, -1/2. So I used the point and I used the slope to write my equation. And I ain't gonna lie, I ain't trying to do with radicals right now. I'm just gonna write in the point slope. Okay?
Wait, what's supposed to be the other way around? Negative 1/2.
No, because -1/2 was the y value.
Oh, sorry. Thinking of the unit circle. I don't know what I'm doing.
So I'm gonna have y plus 1/2 equals negative square root of 3 x minus pi over 3. And that's my equation. It's not pretty. but it's right.
Just wrote it while she wrote it.
Okay. So, do you guys remember? This is refresh your memory. Okay. So